Hello everyone. So here we are going to see different calculations, that involves frequency, period, wavelength, velocity, simple wave equation. So let's go. The first one says a wave completes 200 oscillations in 5 seconds. What is the period? Period is simply total time over number of oscillations. So the total time is 5 seconds. The number of oscillations is 200. Okay, so that is definitely going to give us 0.025. So A is the answer to this. Now number 20, the next one says a wave has a period of 0.002 seconds. What is the frequency? Frequency is simply 1 over period, which means 1 divided by 0.002, and this is 1, 2, 3. This is same thing as saying 1000 over 2, which is 500 hertz. So C is the answer to this question. Now the next one here says a sound wave travels at 340 meters per second with a frequency of 850 hertz. What is the wavelength? Now the velocity of a wave is simply, in this case now we can say frequency times wavelength. Okay, or you can say velocity of wave is wavelength over period, but this is the best formula to use here. And since we are looking for the wavelength, we can say that wavelength is velocity over frequency. So the velocity is 340, the frequency is 850. Okay, so that would give us I think this is going to be 0. If you add an extra 0, it is more likely going to be 432 plus 20, 34. Yeah, so the answer is 0.4. Okay, so number 24, a radio wave has a frequency of 100 megahertz. Given that the speed of light is 3 times 10 raised to the power 8 meters per second, what is the wavelength of this wave? Okay, the frequency of the wave, writing out the parameter, 100 megahertz. Mega means 1 million. So I can say 100 times 10 raised to the power 6 hertz. That's the frequency. And the speed is 3 times 10 raised to the power 8 meters per second. So since we are asked to find wavelength, wavelength is simply the speed over the frequency. So the speed is 3 times 10 raised to the power 8. And while this is 100 times 10 raised to the power 6. So the answer is 3 meters. Okay. Now number 25 says the angular frequency of a wave with frequency 50 hertz is. Now frequency of a wave, the frequency is 50 hertz. The angular frequency is simply 2 pi times the frequency. So that's going to be 2 pi times frequency is 50. So that will be 100 pi radians. So the answer, radians per second, sorry. So the answer is B. Now note that sometimes you may be required to write the value of pi. Pi is 3.142. You can also use that in case the question requires that. Now number 26 says if the angular frequency of a wave is 314 radians per second, what is its frequency? And we're asked to take pi to be 3.14. Now angular frequency is equal to 2 pi times frequency. So that means the frequency of a wave is going to be angular frequency divided by 2 pi. So the angular frequency is 314 divided by 2 times pi. We are asked to use 3.14. I think this would divide this 100. And 100 divided 2 is 50. So that gives us 50 hertz. So B is the answer to that question. Now the next one has to do with simple wave equation. The displacement of a wave is given by y equals 0.05 sine 100 pi t minus 2 pi x meters. What is the amplitude of the wave? Now the simple wave equation is, the original equation is actually a sine, here is omega t then minus kx. Okay, so you can compare both equations. If you compare both equations, you can see that A is actually 0.05 meters. So that's the answer to that question, 0.05 meters. Now the next one is like the first one. from the wave y equal to this, the wavelength of the wave is, if I want to find the wavelength, I write the equation again, y equal to a sine omega t minus kx. Now what you should know is that the formula for omega is 2 pi f, or you say 2 pi over period. Then the formula for k, k is actually called, I try to remember what k is called, but the formula for k is 2 pi over lambda. Okay, we can use, k is called wave number. Okay, in case you're asked. Okay, that is 2 pi over period. So if you compare, you can see that if you compare these two equations, you can see that your k is actually equal to 2 pi. So if we substitute k to be 2 pi over lambda equal to 2 pi, so lambda now would be 2 pi over 2 pi, which is equal to 1. So the formula for lambda is 1. Quite easy. Then the next one says a wavefront is defined as a, the direction in which wave travels, b, a surface connecting all points in a wave that are in the same phase, c says leading edge of a wave packet, then d says the plane of vibration of a transverse wave. A wavefront is simply the direction in which wave travels. Okay, that's important. Now number 30 says, according to Huygens principle, every point on a wave acts as, I know you shouldn't know this, but the answer is B. Okay, this is not part of what you should know. Okay, thank you very much. Thank you. Go through the other videos. There are other videos before this, so you can use that to do a lot of practice here. So see you in my next video. Thank you.